All right, hello algebra students. Going to do a little video today on a pretty radical topic. So you should be on page 829 in your textbooks so we can look at the beginnings of radical expressions. All right, I'm going to ask that you guys read through the section, look at the vocabulary, and I'm just going to point out a few things in this short video. We did a little bit with square roots earlier this year, you might remember, and that's what this topic is. Radicals are another word for square roots. What we are trying to do is simplify a square root expression. So an expression is in simplest form if there are no perfect square factors other than 1 under the square root, and there's no fractions, and there are no more square roots in any denominator. This first set of examples down here shows how we can take a couple of different square roots. For example, the square root of 2 over 72, that's part A, and we can simplify that. We can simplify 2 over 72 to 1 over 36. Well then remember this, the square root of 1 is 1, and the square root of 36 is 6. So that's how we find our answer through a couple of steps in that problem. Next, we've got something being added underneath our square root. Well, you can add 3 squared plus 4 squared, 9 plus 16, which is 25. And the square root of 25 becomes 5. This one, don't worry about too much. We're not going to really get into much of this, but for future reference, you could figure out that the square root of x squared plus 8x plus 16 is actually x plus 4 times x plus 4. So that's written as the square root of x plus 4 squared, but don't worry about that one too much. That's something maybe in the future you would see in an Algebra 2 class. So turning over to page 830, you'd want to read that little box at the top, and then I'm looking at example 2. I want to be able to simplify something like the square root of 18. Well, the square root of 18 is equal to the square root of 9 times 2. The square root of 9, you can see, becomes 3. So the square root of 18 should be broken down to 3 root 2. The next one is all variables, but that's fine. Think about them separately. Think about the square root of x to the 4th and then the square root of y to the 3rd. Where the square root of x to the 4th is just x squared. The square root of y to the 3rd could be broken down to the square root of y squared times the square root of y. And you can see how the square root of y squared is just y. So if you follow the colors in this one, red, blue, and green, you can see how this one works out to a final simplified answer there. There's another chart down here that you can read a little bit about for quotients. And then at the bottom, a couple of division examples that you can take a look at. Finally, on page 831, there's a couple of product and quotient properties together. So those are a little bit of longer problems that you can take a look at those examples and how we use the product and quotient together. And then a fairly in-depth word problem is the last example on page 831.